Starting. It is starting. Hey there, everybody. It is almost, wait for it, wait for it. It is almost 2 hours UTC. I'm keeping an eye on my clock. Keeping an eye on my clock. 2 hours UTC. The shoes come off. This is a casual gathering, so shoes can come off. Yeah, there we go. It is 2 hours UTC, and it is time again for this daily live stream called Astronomy Daily Live. You can call me Cosmic, and here we are again. Let's gather in the circle of friends who share a common passion for everything, sort of the study and the wonder of it all. So I'm constantly in awe. Uh, yeah, that's what drew me into astronomy to begin with. Everything just completely blew me away. The entire universe just blew me away. So as a kid, it's like, okay, well, how do I get into this? How do I get into this? And somehow don't exactly know how because I was way too young, 4 or 5 or so, found out about astronomy, went to the uh, local public library, found the 5 books that they had on astronomy, and completely ate those up and went on from there. So, yeah, welcome everybody. This is just a casual, fun gathering of friends every day to talk astronomy for an hour or so, sometimes a little more, sometimes a little less, something like that. Now, before I forget, this weekend is the Messier Marathon weekend. This is an opportunity uh, because the moon is new. Okay, that means that the moon is not going to be visible in the sky. Um, you have an opportunity to observe most. I don't know. I've heard claims about all 110 Messier objects, and I think that you really can't see. It just so happens. Okay, this is purely coincidence. Um, that there's an opportunity. Well, there's lots of opportunities. The best opportunity to see as many as you possibly can is around the spring equinox for the northern hemisphere. Um, so that's coming up in just a few days. The spring equinox this year is March 20th at 16:15 UTC. So mark your calendars, put it on your phone. So when the alarm goes off at 16:15 UTC, now that's going to obviously be a different time depending on where you are on the planet, but your alarm will go off and you can uh, at least at least take note. Just sit back and be like, ah, the sun has now crossed the celestial equator. It no longer has a negative declination. It now has a positive declination, and it will have a positive declination until the um, um, the autumnal um, equinox uh, next fall, at least in the northern hemisphere. So yeah, pretty awesome. pretty awesome. Anyway, this time of year, just coincidentally, coincidentally, um, all but one, all but one of the Messier objects are visible in a single night. And not having the moon up, that's even a better chance. So this is a pretty rare opportunity to have a pretty successful Messier marathon. It just so happens that the moon is new, and so it's not going to be um, visible in the sky, and making it even all that harder to find all these objects. Now, if you're a true observer, if you're a true observer, you are not going to use any kind of go-to automated telescope like this one, okay? Because typing in M1 or whatever the object is that I'm going for, um, and having the telescope find it, and you just merely looking at it, which is awesome, but part of the Messier marathon, okay, hence the name marathon, is that you have to do it. So if you're a true if you're a true observer, you will find a manual telescope, one that you can move yourself. Unfortunately, this telescope behind me does not have a clutch at all. So there is no way that I know of that I can manually move this scope around. So um, I've done the Messier Marathon probably 6 or 7 times or so. So I don't I don't do the marathon anymore. It's but it is awesome, and it is an incredible challenge, and it's incredibly fun, and uh, it's difficult. It's difficult in many ways, right? You have to observe. I believe you can see. It's possible to see 109 of the 110 objects. I've heard things today that you can see all 110, and um, mm, there's one object, I believe it's M30, that is more or less in conjunction with the sun right now. We can check that out. Um, if Uncle Bill is on, I'll bet you he's already on it. But you can check that out. Do I have my chat up here? I've got things blocking my screen. I've got some show and tell tonight. I do not, because I did not load the chat to begin with. So come on in, friends. Let's talk astronomy for an hour or so. If you missed today's show, well, just come by tomorrow or come by the next day. My so far my records have shown that tomorrow does arrive. Now, the Beatles said that something like tomorrow never comes. And, well, technically speaking, I guess that's right, because that Space TV, hey, good morning from the UK. Dude, you are up at 2 a.m. Holy moly! Thanks for coming in. That's very awesome. Um, this this device behind me here is it can be a telescope, but it can also at least perform the function of a um, coffee machine, in that it does keep me up at night. So it certainly does. Kept me up last night for a little while. Um, Uncle Bill waving in the house. Hey, hey, hey. Nice, nice to see you. And yeah, very, very cool. So what I was saying about the marathon is make sure to go and do it. If you haven't done it, you should do it. And if you can't do it yourself, find some friends. Go, go find um, the local like astronomy club, and there are people. There are people this weekend. Okay, this weekend, who are doing it. So even if you can't on your own, but still want to, there's lots of opportunity to do that. Also, make sure it's about a half an hour after sunset. You got to look west, look west, and you will see Venus, bright Venus, and to its upper right, a couple of fingers, 2 or 3 fingers wide or so, um, set at arm's length. Uh, um, um, is the planet Mercury. So it's not incredibly rare to see Mercury, but it's relatively rare. It's pretty close to the sun, and and uh, and so it's hard to see. It's hard to see. So yeah, take a look at Mercury also. So it's an action-packed weekend. Action-packed. And oh my gosh, you know what I forgot? I don't have any room on my. I am almost out. I'm almost out of hydrogen hydroxide. Holy moly, what am I going to do? I don't know. I'm going to have to take small sips. Cheers. This is one of the most miraculous chemicals ever. It's amazing. It is mind blowing what this stuff is. Incredible. So simple, yet so fantastic. So, cheers. All right. So, I'm pretty tired, and it's really strange. I don't know if this happens to others. Uh, I was up observing last night. I'm preparing for a very a very neat project that I hope is going to go here pretty soon. But I'm trying to parameterize the scope. How well can it do things? Um, and so I've got to collect data to do that. So there I was last night. It was clear. It was really, really cool. The wind was blowing like crazy here all day long. I mean, really blowing hard, right? And the clouds were just sort of, fluffing around. They were the puffy ones, just here and there, but they were all around, and all of that. And the sun set, the clouds went, and the wind stopped. It literally stopped. A couple of times last night, I got a few minutes of a little bit of a wind, but it just stopped. So the sky cleared, the wind stopped. It's pretty cold. It was supposed to drop into the 30s Fahrenheit here. So relatively speaking, that's not too bad. I'm in southeastern Arizona, United States, space TV, and yeah, so I'm in a very, very, very dark place. I can just walk right outside, and I have a very, 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 very black sky. Measurements around here have shown that it can get down to 20 seconds magnitude per square arc second, which is very, very, very dark. That's as dark. That's um, um, pretty much as dark as you can get. So yeah, lucky enough, and it, relatively speaking, it does not get cold here, but relatively speaking, it gets cold. So having to be outside, um, uh, uh, it got a little bit cold. But the really weird thing is, okay, and this happens uh, uh, um, every single time I do this. I got the same amount of sleep as I normally do. Okay, normal amount of sleep, right? But my sleep time changed, right? I went to bed, it was around midnight local time. I'm usually in bed by, 9ish or so local time. So that 3 hour shift, right? The 3 hour shift, okay, same amount of time, just a different sort of, time area, um, just completely just wipes me out. So I did not get any less sleep last night, but I feel as though I'm like, I'm a zombie. I've been a zombie all day. It's been, just sort of one of those weird ghost days where it's just like, you know, everything's just sort of, but I'll be with you at least for the hour. This is a circle of friends. We're talking astronomy, and astronomy will keep me up for sure. So I guess what I thought I would do is just a little bit more show and tell tonight. Um, One of the questions that new people ask is, what kind of books should I get? To sort of um, um, get me a good introduction um, 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 into astronomy, and you know be entertaining and educational and all of that. And I don't know if I would say that this book that I'm going to show you here is my number one book for that, but it's definitely in terms of for new people and for kids, not young kids, but 10 or above. Um, this is very, very awesome, and that is that book right there. So this book I got this when it first came out. Uh, Lost the cover eons ago because I got this in 1980. So I don't think when I got this, I don't think that the series had started yet. I think it was going to start in 80 or 81. I don't remember exactly when it started, but Carl Sagan's Cosmos um, came came to me at. I mean, the timing could not have been any better. I think I was 11, 10 or 11, something like that. See if I could see Venus, but according to Google Sky Map, uh, oh yeah, you have to Space TV. You've got to look at Venus. No, well, if you go 30 minutes after sunset and look west, it's that big bright star to the west. And as I said, right now, at least, just um, um, up and to the right, about 3 fingers or so, is a fainter star, which is the planet Mercury. So make sure to take a look at that. Uh, um, uh, I've seen the Sky Map app, and I think for yeah, I think it's actually probably useful. I actually I'm old school. I'm old school. Let me. I use uh, I use charts. I use sky charts. So something to actually hold in the hand, ink on paper. That does not mean that I don't think um, um, that apps like SkyMap are are bad or dumb. I think they're very awesome. My attitude is that anything that um, keeps you excited and motivated um, to go out and look and learn and be just blown away. It doesn't really matter what the tool is. So if you like it, do it. Um, Stellarium uh, is great too, and yeah, um, Space TV. Um, Uncle Bill there, he's gonna pull you in. So just hang on. He will pull you in. Just say yes. Just say yes, and he'll get you hooked in with everything. Um, Uncle Bill is a ninja. He's he's doing 60 things at the same time, and he'll help you. Yeah, I've got a link to my Discord channel down in the links, down in the description below. You can also see my Twitter there. That's Astro and Music. And I think I've got a link to this um, YouTube channel. Cool. Well, glad you could join the circle of friends. So, anyway, yeah, this book, Cosmos, was a great um, influence on me. This uh, I I was already set to get going into astronomy, no problem at all. But this kind of thing, Carl Sagan, and this book was certainly um, incredibly incredibly awesome fuel. So, oh wow, it's actually a little bit warm. Take this jacket off. Pretty amazing. Yeah, see, Uncle Bill is teaching Linux right now on another server. Uncle Bill, you are amazing. You are amazing. I'm so glad that you're here. I'm so glad. It's very awesome. So, I highly recommend this book, the Carl Sagan version of Cosmos. Now, I've got to tell you that I am heavily biased towards this version of Cosmos, not um, Tyson's version. That is a completely personal thing. Um, Nothing against that at all. If if that one works for you, do it, do it. But I'm I'm gonna recommend I'm gonna recommend that one. that one for sure. So once you've, I'm just going to read the chapters here. So chapter 1 is called The Shores of the Cosmic Ocean. Chapter 2 is One Voice in the Cosmic Fugue. Chapter 3 is The Harmony of the Worlds. I don't know why I'm not getting good lighting here tonight. Chapter 4 is called Heaven and Hell. Chapter 5 is called Blues for a Red Planet. And let me tell you something. The music in that, well, I'll get to that, I guess. The music in that um, episode is fantastic. It's fantastic. Chapter 6 is called Traveler's Tales. Chapter 7 is called The Backbone of Night. Chapter 8 is called Travels in Space and Time. Yeah, I'm just having lighting problems tonight. Chapter 9 is called The Lives of the Stars. Chapter 10 is The Edge of Forever. The Edge of Forever. Chapter 11 is called The Persistence of Memory. Chapter 12 is called Encyclopedia Galactica. And chapter 13 is called Who Speaks for Earth. So this is, this was written in the late 70s. So, a lot of things are definitely not up to date anymore. But the basic concept, I just found something interesting. Okay, I'll have to look at that later. But the concepts and the thinking, the scientific process, discovery, the awe, the wonder, the awesomeness of the universe is that doesn't change. That doesn't change. I guess if it does change at all, it just gets better and better and better. So we we think we know so much more now, and as far as I'm concerned, that just makes it better. So yeah, let me. There's that. It's really hard for me to show you these things out of books, but I'll just let me find some. So here's chapter 7, the backbone of night. So yeah, I of course ate this up. As I said, Cosmos came to me at the absolute perfect time. Um, just it was a booster rocket. Okay, I was already going right. Um, but Cosmos came along, and yeah, it was a booster rocket. Hey there, Tom. Nice to see you. Nice to see you. Let's see. So yeah, I for new folks, pick up a copy of Carl Sagan's Cosmos, the book, right? Book. Now, of course, he also did a television series. It was a 13-part series, and I am lucky enough. I am lucky enough to have that on DVD. Now, this is unfortunately the updated version. So some of the graphics aren't the original graphics in the original show, which I prefer. Um, it's a yeah, they did the same kind of thing to the original um, Star Trek. They changed a little bit of the graphics, and it just isn't as good. It isn't as good as the original. Now that's totally biased, right? That is just my horribly biased attitude. So, but yeah, this is awesome, and of course, the episodes follow um, um, the chapters in the book. So are there 13? Where did that book go? Are there 13 chapters in this book? Okay, yeah. there are. Okay. So there are 13 chapters in the book, and there are 13 episodes on the DVD, right? And so each chapter was a different episode, and yeah, it's very awesome. So um, get the book, read the book, use it as a reference, but also pick up the DVD of the actual show, because then you will be completely immersed in Cosmos and yeah, all of its awesomeness. Um, so let's see. The other the other thing, if you want to go even beyond that, is you can pick up the Cosmos soundtrack. It's called The Music of Cosmos. And this is all, of course, the music that was used on the series. And it's a 2 CD set. 2 CDs. Here's disc 2. And yeah, I play this pretty often. And in fact, what I have done in the past, and I need to do this again. I need to rip these to MP3s so I can play them while I work, because there is nothing better for me while I'm working, writing code or um, doing some kind of um, um, astronomical analysis, to have some nice music in the ears. And I'll listen to space music. Um, if you haven't heard of a show called Music from the Hearts of Space, they've they've been playing space music since the mid 80s, and they have a weekly show. It's HOS.com. They have a weekly show. It's free on Sundays. So I recommend, if you haven't yet, go over there, take a listen. You can subscribe too. There are some levels, and um, you know, you can do um, um, on-demand type of stuff. I'm I'm too poor to be able to afford that kind of stuff, so I just listen to the free shows on Sunday. And what I do is I record them, and then I have a copy of them, of course, and I can listen to them whenever I want. Now, is that a violation of copyright and all of that? I suppose it is, but I'm not selling it. I'm not really even sharing it. It's for my ears only, and I like to listen, to that kind of stuff. Or, you know, I'll pick up this and throw it in, and while I work, having that in my ear is just absolutely gorgeous. So yeah, very awesome. So yeah, if you're new to astronomy, pick up Carl Sagan's Cosmos for sure, for sure. And watch the new series too. I'm I'm uh, as I said, I'm incredibly biased. I'm incredibly biased, so I prefer Carl Sagan's version. But Neil deGrasse Tyson did a very awesome job, and um, definitely take a look at that too. And if you like it, watch it several times. I need to get a copy of it, even though I'm really it sort of makes my skin crawl. But that's showing my incredible bias. And as a scientist, see, um, you have to be sensitive to biases because you're trying to look at things, you know, without those. And so you have to be able to identify them in order to sort of remove them, right? So I know that I've got a bias towards um, Carl Sagan's cosmos, just because that's what got me going. Um, I'm hopeful that Neil Tyson's version has also done a lot of inspirational stuff uh, for kids these days. So that's okay. That's all right. You know, they will be on a different path than I, and that's okay. We don't have to be on the same path. Um, Thoreau said you know, uh, find your own path, and march to the beat of your own drum. So I greatly encourage that for sure. So all right, um, I'm thinking. Let's see, what should we do? We're a little more than halfway through this. Um, how about another Bucky book, Buckminster Fuller book? Yeah, I haven't looked at a Bucky book in quite a while. Quite a while. And Bucky is very awesome. Let's take a look at that. Okay, hold on 1 sec. I'll be right back. So this is another one of Buckminster Fuller's books. It's called Critical Path. I don't think it has any kind of subtitle or anything. It was published in 1981. Okay, so maybe a little dated again. And yeah, there's really not, in terms of the contents, there's not a lot of content in the contents. Wow. Well, because of that, maybe I'm not going to get into this too much. Too much. But I recommend this. Bucky is a pretty hard read. It's a pretty hard read, but pretty interesting stuff. Buckminster Fuller was a uh, genius beyond genius, uh, and not really talked about or mentioned much, but very awesome, Very, very awesome. Great, great, great book. I haven't actually looked at this book in quite a while. So probably what I should do is spend a little bit of time going through it again, especially because I'm finding pieces of paper in this book that I don't know why they're here. Little little bookmarks, little little pink sheets, little little pink sheets. Huh. Okay. Hmm. I'm just finding all kinds of interesting pieces of paper in these books that I'm showing you. That's very cool. But yeah, if you haven't learned about Bucky Fuller yet, definitely check him out. I would say, actually, Critical Path is also one of those books that's a pretty good introduction. Um, so yeah, I would definitely recommend that one. The other one, the other one of Bucky's that I would recommend is this one called Nine Chains to the Moon. This was written, this was originally written, ooh, I want to say, yeah, this book was originally written in 1938. 1938, so that's 80 years ago. This book was written. This particular book looks like it was updated in 1963. So still seems to be old, but let me tell you, um, uh, not much has changed. Not much has changed. So take a look at this book too. As I said, um, Bucky Fuller is a hard read. Is a very hard read. Um, the other thing, I think maybe you can find this on YouTube also. If you look for um, Buckminster Fuller and then uh, everything I know, everything I know, he did a lecture that spans several days, several day long lecture. Now this guy talks. Okay, this guy talks about 100,000 miles an hour. Okay, and he talked intensely, intensely for I don't know how many hours hours it was. It was just, as I said, I mean, it went on for several days, and it I firmly believe that it was everything he knew, and so take a look at that, and um, take a listen, and you'll you'll understand um, what I'm saying. Bucky takes some time to get used to. Once you do, though, it's it's pretty easy, uh, uh, at least to follow him, to understand him. He's very very exact. He's very exact in his words. But yeah, so I recommend all of those things. If you're a little more advanced in terms of astronomy, this is a pretty good book. Astronomical image. So this just goes through sort of ad nauseum about how to collect um, images with CCD cameras that are attached to telescopes, and what you have to do to reduce that data down. Get rid of all the systematics, and just show the actual um, information that is coming from the object that you are making an observation of, and it's not easy, and it can be tedious, but that's part of the whole thing. That's part of the whole thing. If you want to know the answers, you got to work for it. So yeah, this is a pretty good book. Good reference book again. Um, Lots of chapters. Basic imaging, digital image formats, how to make good CCD images, image calibration, the tools of um, um, image analysis, checking CCD performance, astrometry, photometry, spectroscopy, geometric transforms, point operations, linear operators, conditional operators. It just goes on and on and on. Color imaging. Great, great book. Great book. Yeah. Let's do Space TV is in, he thinks. Maybe he or she. Space TV is a neutral gender name for sure. So I'm presuming. Okay, well that's funny. Yeah, uh, 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 pausing a live stream makes chat rather difficult. So I recommend just doing a refresh, and if you really want to, you can just go back later. Let's do an object of the day, shall we? And I need another swig from my very meager uh, uh, pile of molecules here. Let's let's see. 1 mole of something is 10 to the 24th actual particles, and hydrogen hydroxide um, has a molecular weight. Let's see, oxygen is 16, and hydrogen is 1, so that's 18. So 18 grams of hydrogen hydroxide has 10 to the 24th molecules in it. So is this 18 grams? 18 grams is it's about half an ounce. Yeah, you know what? I'm thinking that I've got about 10 to the 24th molecules of hydrogen hydroxide left. So, I'm awfully thirsty, and I could definitely use 10 to the 24th of those molecules. I can definitely enjoy every single one of them. So here we go. This may take a while. It's 10 to the 24th of them. Cheers. Awesome. Yeah. 1 mole of hydrogen hydroxide. That's a lot of stuff. That's a lot of stuff. All right. Let's do an object of the day. So I'm going to share my screen, and uh, I'm sort of a contrarian. So it's Messier marathon weekend, but let's choose from the NGC catalog. NGC stands for New General Catalog, and this is a catalog of non-stellar objects. So these are things that aren't stars. Get out of there. These are things that aren't stars. So playing me on 1.5 speed to catch up. Oh, that that's something maybe I should look at to see, how much worse it actually is. Um, so the NGC catalog contains 7,840 non-stellar objects. So these can be galaxies, they can be globular clusters, open clusters, planetary nebulae, and diffuse nebulae. And they span the entire sky, so they're in the north and the south. Um, Numerically, they're in basically order of right ascension. So a right ascension of 0 hours, you're going to have sort of the low um, 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 NGC numbers, and then it goes all the way around to an RA of almost 24 hours, where you have the highest numbers. So I'm gonna I've gone over to random.org, and I'm going to ask it to choose an integer between 1 and 7840. And it is going to choose our object of the day. So drum roll, please. All right, NGC 2215. So just from that number, I I can get a pretty good idea as to where it is in the sky, right? 2215 divided by 7840. Now I've just grabbed my calculator from my desk. And as I say, every good scientist has a hand calculator within reach at all times. So here's mine. That's a little less than a third of the way through the NGC catalog. So that means that it's about a third of the way through right ascension. So it's going to be around 8 hours or so. So that puts it just a little bit east of the constellation um, um, Orion. Uh, but it could be way north of Orion. It could be way south of Orion. We don't know yet. But what we're going to do is we're going to go over to Simbad, which is an astronomical database where we can find out all kinds of useful and interesting information about, what was it, NGC 2215. So I'm just going to type in NGC 2215. Now, most likely, this is going to be a galaxy, but I don't know. In that area of the sky, there aren't really a lot of galaxies. There's a lot of open clusters. There's some planetary nebulae. I don't know. Let's find out. NGC 22, let's make sure, 2215. Yeah. 2215. Let's see what it is. It's an open cluster. Very cool. So this is showing the equatorial coordinates in right ascension. That's what these first three numbers are, and declination. So this is really close actually to the constellation um, um, Orion. Very close, in fact. So let's see. It's moving towards us. This cluster of stars looks like it's moving towards us at about 3.4 kilometers per second. It's pretty faint. It has a V magnitude of 8.45. We can see down to about sixth with our own eyes. So you definitely need you definitely need a scope to see this guy. because he looks like he's small and faint. Small and faint. So past 20 years, this object has been referenced 23 times. That's not too bad. We'll look at that again in a little bit. Here's a distance measurement. See how far away they think this thing is. So this says it's 1,293 parsecs. And a parsec is 3.26 light years. So 3.26 times 1293 is 4,215 light years away. So if we were to go out, now and look at this object through a telescope, we would see it as it was 4,200 years ago. So that light is just getting to us now. So relatively speaking, that's really, really, really close to us. Super, super close. But that is right in the galactic plane. So there's going to be a lot of stars in that area. It's in a part of the galactic plane where we're sort of looking out as opposed to looking towards the center. We're turned 180 degrees around and are looking out instead. And we're about, well, we're located, I should say, about 2/3 of the way from the center. So we can still look out and actually see a little bit of the Milky Way there. But let's just see. We're gonna pull up this view of this field of view here. It's always zoomed way out. So they're saying that this is a cluster of stars. And a cluster of stars, that just means that they've observed these stars enough to notice that they're all sort of moving in the same way, right? And as you can see, wow, we've got a shitload of stars here. And that is because we're looking right through the galactic plane. As you can see, there's sort of a concentration, and let's move this off to the side so you're not biased by the marker there. And I'm going to zoom out one more time just so you can really get an effect. See how if you sort of look at this whole field of view, there's one spot that has just a little higher concentration than everywhere else. Well, that's it. That's NGC 2215. So they've apparently measured the motions of all these stars, and the theory goes, at least, is that all these stars formed at the same time from the same cloud of gas and dust. And so since they all formed at the same time from the same location, at least the theory goes that they're all moving in sort of the same way. Not necessarily gravitationally bound, but yeah, somewhat, right? But you can definitely tell that there's a concentration of stars here. And if you look, sort of carefully, you can tell that, yeah, they all seem to have sort of the more or less the same brightness, more or less the same color. There's a couple of orange ones in here. Look, but a lot of these look sort of bluish or whitish. Yeah. So that sort of indicates, at least, that all these stars are pretty much the same age, probably, part of the same cluster. Yeah. All right, well, cool. Let's look at these references, because a lot of times the references in the professional papers, which don't be afraid of these things. As I say, you know, uh, all the time, these are means, for you to learn a lot. Um, Even if it's, way over your head. I mean, these papers are over practically everybody's head. You know, the pros, you know, don't understand a lot of these things either, but you read these kinds of things in order to learn more. So let's take a look here. See if we can find one. Ooh, here we go. Photometric and proper. Hey, look at this. Photometric and proper motion study of the neglected open cluster NGC 2215. Now, these are my kind of people, okay, who are like, look, nobody's paying attention to this um, cluster of stars. Everything, everything out there is an opportunity to learn a little bit more. Okay, nothing is the same. Nothing, and and everything is constantly changing. It's constantly changing, evolving, moving. You know, the variety is endless. So these guys recognized that and said, "Hey, let's just do some basic looking." So they're going to be looking at the brightnesses and the motions of all the stars inside of NGC 2215. So that's very, very cool. Let's take a look at the paper. We can come down here and go to ADS, which is the Astrophysics Data System. If you want to find any paper at all, um, oldish type, go to ADS. That's a great uh, launching point. So we can pull up the paper itself, the actual scientific paper, and as I said, don't be um, 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 intimidated by these things. If you don't understand stuff, so what? Move on. What I do is I try to find pictures, try to find lots of pictures, because the pictures I can, it's just like being a kid again, right? You got your picture book, and that's where you start. And there's nothing wrong um, with that at all. Got to start somewhere. So let's see here. Optical UVBRI photometric measurements using FTN taken in early 2011 and combined with that, blah, 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 to estimate the main parameters of the galactic open cluster NGC 2215. Um, so, yeah, pretty small. They're saying, an outer radius of 4.3 arc minutes. So, yeah, that's pretty small. Distant, okay, an age, see, it's a log of the time. So you have to go 10 to the 8.85, 10 to the 8.85. So they're saying that this cluster is about 700 million years old, and it is, these guys are saying 790 parsecs. Now the thing in on Simbad said like 1,200 parsecs. So 790 is a little closer, 3.26. So about 2,500, 2,600 light years away. Proportion of this work was undertaken. Okay, cool. So a lot of this work was done actually by high school kids. That's cool. Doesn't matter who does it. Man, if I was a high school kid and could do this, man, I would have been in absolute heaven. I didn't even know any of this kind of stuff existed. Well, I guess as a high school kid I did. So these papers, most papers, they follow sort of a general formula. They sort of lay out um, um, basic information. If there's any kind of history or some kind of weird problem or anything else. The introduction talks about that, and all of these blue things are links to references, and references, these are your um, um, launching points to learn more, because you can learn more and more and more and more and more. It's amazing. So you don't have to start and end with this paper. This is the beginning, just the beginning. So then they talk about observations. They got some nice pictures. See, there come the pictures. And I like to read, the figures underneath, see if I can understand that. So yeah, here are those orangish red stars again, that we saw in the other one. This is a slightly different picture, but of course the stars are the same. Here's some math over here. Good. You like math? Let's see. Photometry of images was undertaken via APT, aperture photometry, using a 4 pixel radius. Yeah, just all the usual stuff. So here, okay, so these are residuals to the fit of standard stars. So yeah, in order to measure the actual brightnesses of these stars, you have to compare them to um, stars of known brightness. Uh, and so you also make um, 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 observations of those so-called standard stars. And so this, um, these are just plots showing, how well they were able, to measure the brightnesses of the standard stars, because that, of course, gives you an idea of how well you're going to be able to measure the brightnesses of the stars that you're interested in. So let's see, they talk about the size of the cluster. Let's see, photometry. So that's that. What's section 2? Comparison to previous photometry. Okay. This thing has been looked at a lot, since 1987, it looks like. Size of the cluster. So they're saying, let's see, this is just an apparent size in the sky. So maybe they'll talk about how big they actually think that is uh, somewhere else. But you need to know how far away it is in order to figure that out. What is all this? From left to right, these values, ID. Okay, so this is just samples of the data. These are the brightnesses of the individual stars in B magnitudes, in V magnitude, R and I. These are just different um, filters. They're different wavelengths of light. So B and V and R are sort of visible. I, H, K, all of these are towards the infrared. Okay, so that's just showing that as as the stars got fainter, their ability, to measure the brightness got worse. That makes sense. Let's see. So here's a color diagram. It's sort of like a Hertzsprung Russell diagram. It just it just shows the populations and relationships between the stars that are part of the cluster. That is. Oh, I'm running over time, so let me fly through this a little bit. Mean cluster proper motion. So let's see. They're saying that it's moving. Let's see. Lots of numbers here, but pretty much, yeah. I don't know if they're in agreement or not. Okay, here's a vector proper motion diagram of each of the stars. So not a lot of motion. See, these are all around 0, both in right ascension and deck. And some of the stars they sampled are moving quite a bit more. So are they, part of the cluster or not? Probably not. I'll bet you that this red circle um, indicates cluster membership. Let's see. The dashed. Okay, no, that's just a. Yeah, well, that's how I would sort of read that. I think they're saying pretty much the same thing here. Color magnitude diagram. So let's see. The circles are stars that they are calling non-members, uh, and the plus symbols don't have any proper motion. Uh, and let's see, the filled ones. So I guess the filled ones here are identified members of of the cluster. So yeah, yeah, I think these are looking like red giants over here, but most of these look like I think you would call those main sequence stars. So very, very cool. So a distance of 790 parsecs. Um, that age. Whoop, I went too far. Yeah, these guys used a robotic network of telescopes. Um, Las Cumbres Observatory, very, very awesome. Expensive, but very, very awesome. So here's some more plots, color magnitude diagrams. Very cool. And there's all your references. So each one of these is a jumping off point into learning even more. So this is very awesome. They took a neglected open cluster and just did some basic observations, basic basic observations, got their hands dirty, and that's always very awesome. So yeah, very, very cool. All right, I think I'm going to get out of here for tonight. I'm going to stop sharing that. I'm going to come back over here. Yeah. All right. I think that was a good hour. Um, Hope you enjoyed. Um, Make sure to subscribe to this channel if you haven't already. You can set the notification bell to let you know um, when this is happening. If you like this kind of stuff, hit the thumbs up, hit the thumbs down. If you don't, I just like a reaction. And so, yeah, whatever you like, whatever you like. So make sure to share this. I'm definitely trying, to grow a crowd. I think it'll be really, really fun when there's a larger crowd here, because the conversation can just be awesome, just be very, very awesome. So yeah, spread the word. Space TV, thanks for coming in. Come in anytime. You don't, you know, don't feel as though you have to show up here each day. Come in once a week or once a month. Um, um, Whenever you want, the door is always open. So yeah, glad you could join the crowd. And yeah, I will be doing this again tomorrow, same time, same place. You're, you know, watching this at 2 a.m. Space TV. You're awesome. That's absolutely fantastic. Um, Great surprise. Yeah. So I'm glad you're here. As I said, don't feel as though you have to, but you are more than welcome here to come in anytime, anytime. But I'm here every single day at 2 hours UTC. We go for about an hour or so. It usually runs um, more than that because I can talk astronomy day and night, day and night. So yeah. All right, I'm gonna get out of here. Let's see. Yeah, the ship is calling, so I'm gonna get out of here for now. I will see you again on the spin in a little less than 23 hours. Okay, have a great day, a great evening, and yeah, if you're gonna do the marathon, let me know how that goes. It's always fun. All right, I'm gonna get out of here. Peace, cheers. See you tomorrow. Bye.